Greetings everybody. This video will hopefully explain how to do online lab number 6. It's called the Energy Skate Park. It is a conservation of energy lab. And here's the template. I've got it open for you. And notice there are 3 sheets. Sheets 1 and 2 are the Energy Skate Park. And notice sheets 1 and 2, see it says no friction and no friction. And then sheet 3 is Energy Skate Park with friction. Okay, and I'll probably break this video up into 2 or 3 parts. Well, let's look at what's going on with sheet 1. Okay, well, let's go ahead and let me open up the simulation and explain what's going on. Okay, now for sheet 1, you want to do the intro. And then sheets 2 and 3 are going to be playground. So let's do intro. Now what's going on is basically what we're doing is I can take the skateboarder and I can set him up to a certain height on this skateboard track. Now that height is indicated by the red dot at the bottom of the skate on the skateboard right there. That red dot is how I put the skateboarder at a specific height. And notice here you have in this box to the right you have pie chart. Well, I want to select bar graph, grid, and speed. And see, the speed is given by this speedometer here. It's in units of meters per second, but notice it's incremented. All the minor tick marks are 1 and the major tick marks are 2. So in other words, this is right now the red, it's 0. And again, in meters per second, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You get it. Not very trivial. All right. Now, what we're doing is you're going to set the skateboarder and release him from rest at these various heights. You're going to start off. So starting off with a height of 0. Then put them at a height, this is in meters, so 0, 1, 2, 3, 4, 5, and 6. Then I want what I call V low. All I want is I want the speed of the skateboarder when he's at the lowest point of the skateboard track, right here, at a height of 0. And so what you do again, so I want to start off the way they're entered in the spreadsheet. I'll start off at 0, and then 1, 2, 3, all the way up to 6. And what I want to do is I want to record the speed at the low point from the speed that the simulation gives me, and then the speed that the theory, that conservation of energy, gives me. Well, why is the theoretical speed root 2gh? Well, right here in the instructions. Sheet 1, by conservation of energy, when we set the skateboarder up here to a height at 6, well, he's being released from rest. He's being released from rest. And then, so he has no kinetic energy. Then I want to know, I'll put slow motion mode. I want to know what is his speed when he hits the bottom, i.e. the low point of the skateboard track. So, and notice I'm on slow motion. Now, as he gets closer to the bottom, I can pause it. And when I do that, after I hit pause, if I hit this button here, I can move him to the low point incrementally. See? And I know that when he's at the low point, his height should be 0. So I want to make sure that blue bar indicating the potential energy, I want to make sure that that bar is completely gone. Right there. And I could probably go one more. So that right there, his height is 0, meaning he has no potential energy, meaning no gravitational potential energy. And I want to get his speed from the speedometer. And remember, this would be, again, that's 0, that's 2, 4, 6, 8, 10, and it looks like practically 11. It looks like it's probably 10.9 meters per second. So that's the V from the simulation. Go to the spreadsheet, and well, actually, I forgot. Let me pause it. Okay, so here I've set the skateboarder. He's at a height of 1 because see the grid, 0 meters. Each square is 1 meter. So 0, 1, 2, 3, 4, 5, 6. So right now, I've set him at a height of 1. And I'm going to hit play. Then I want to determine what is his speed when he's at right at the low point, right at a height of 0. I'm going to pause it. I'm going to inch him towards it. There. That red dot, his height is 0. Notice the bar for potential energy is 0. Now I want to go ahead and look at his speed. And again, this is 0. Every major tick mark, that's 0, 2, 4, 6, 8, 10. The minor tick marks are 1. That's 0, 1, 2, 3, 4. That's 5. It looks like it's not quite halfway between 4 and 5. It's not quite, so it's not 4.5. It's probably around 4.3. So when the height was 1, I got that from the simulation, when the height is 1, I got that the speed is, what did I say, 4.3 meters per second. Now at a height of 0, when he starts at a height of 0, obviously his speed is 0. Okay, right there. I'm going to start him. I'm going to take him back. I'm going to put him right there at a height of 0. What is his speed? 0. Okay, so that's that guy right there. Okay. Now let me go ahead and get all the simulation values. I'm going to go set them at 2, 3, up to 6. Let me pause this while I do that. Okay, now I'm ready to get the last speed from the simulation. I'm going to set the skateboarder up at a height of 4. Okay. I mean a height of 6, excuse me. So he's right there at 6. Okay. I'm going to hit play. Then as he gets closer, I'm going to hit pause. And then see, I'm almost there. Increment right there. Notice no gravitational potential energy. And notice the speed is, again, 2, 4, 6, 8, 10. Looks like about 10.8, 10.9. I'll do 10.9. All right. So I've got all my speeds from the simulation. Again, when I say V low, I mean what is the speed of the skateboarder at the lowest part. And remember, in each case, he was released from rest. See, he's at rest. And then you hit play. And then we just want, by V low, I mean what is the speed when he goes through when he's at the lowest point of the track. Again, pause, inch him forward. Again, looks like, again, that's 2, 4, 6, 8, 10, probably not quite 11. All right, anyway, so we got that. Okay, now I need to get the theoretical speed at that low point. Well, by conservation of energy, as explained in the instructions, in this Word file, right there, sheet 1. Well, by conservation of energy, mgh is 1/2 mv squared. Nothing complicated. Solve for v. You get v is root 2gh. Well, you have to enter this formula into cell D9. So what you'll do is you have to do this. In cell D9, I need to enter that formula. Well, in Excel language, it's equals. I like to do a lot of spaces and a lot of parentheses. Equals space, left parenthesis space. I need the square root of 2gh. Well, the square root function is sqrt. Okay, see. I need a left parenthesis. Now I need 2 times, asterisk. And notice I need g, the numerical value for g. Well, notice that's in cell F4. So notice when I clicked on it, it automatically put it in the formula. Just to be on the safe side, remember I want the dollar signs. I want $F, $4. Because again, that 9.80, that's the numerical value of g in MKS units, in meters per second squared. That value never changes, and it's always in cell F4. So $F, $4 means, hey, don't change that cell reference. Now the height is in the B column, and it's starting off. It's initially in. I want times, so I'll do an asterisk. Then initially, the first type it's in B9. So click there. B9 automatically shows up in the formula. Close the parentheses for the square root, and then space and another one for the outer. Now hit check. And notice it's 0. And I've already entered in the percent error formula for you. Now the beauty is, once you get this formula typed into D9, hold the mouse over it. When you see the crosshair over the lower right corner, hold down the left mouse button and drag this down. Oh, I got to go one more. Not a big deal. There we go. Now notice it automatically updated the percent error. You see, and see, I've read that odometer pretty carefully. All right, so now you're done with sheet 1. Let me go ahead and save this video, and then we'll talk about sheets 2 and sheets 3.